2. What's the highest possible outcome? 12. And then as we talked about a long time ago, 7 is the most likely. So your sample space goes from 2 up till 12 when we're talking about dice. Where we got confused yesterday was talking about the sample space for people. So if it's all possible outcomes, and we're picking a group of 2 people, I could pick Kim and Pat. I could pick Kim and Sue. I could pick Pat and Sue. D actually repeats Kim and Sue, Sue and Kim. So D does what we call over-counting. So our correct answer here for all the possible groups is Kim Pat, Kim Sue, Pat Sue. 3 possible groups. So C would be our correct answer there. Your sample space is the possible outcomes. Right? Possible outcomes. Questions on that one? Because I promised you guys we would circle back to that. Now we got to remember where we left off at the end of the day yesterday. I think we were on the volume one, right? Amanda, can I help you with anything? I gave you this packet yesterday at the computers. There's one right there. Just grab an extra one. You got to bring your stuff back so we don't waste paper. All right, so guys, yesterday we ended off on this question, but does anyone still have questions about how we found the amount of meters cubed? Because that was like, we took a meter, cubed it. We don't even have a whole meter cubed. Guys, visualize this with me. A meter cube. Make a cube this big. So this wide, this far out, this deep. That's a lot of water, right? So that's why they then tell us that meter cubed is equal to 1,000 liters. Because guys, a liter is not very, like, this is over a liter, right? A liter's not that much. Actually, I think this is a liter. Which if I drink a liter of coffee, maybe I should reassess that. That might not be a liter. I might be a little off. But you know what a 2-liter bottle looks like? Like a 2-liter bottle of soda? That's 2 liters. So we multiply by 1,000 because that was our conversion factor, and we got 132 liters. Now somebody asked a really good question at the end of class. Why isn't this cubed? Liters is a volume measurement. That's it. Liters cannot measure like length of something. So if I pull out a piece of string, I can't talk about string using liters. Liters has to be talking about volume. How much coffee I have in my cup, how much water in my bottle. Like, liters is volume. Any other questions about that problem before we move on? All right. So all of the bottom part of your paper goes together. So I want to give you a minute to read through and highlight the important parts of this problem. And remember, you have that highlighting tool in the test, like on the computer. You can highlight on the computer. There might not just be one right answer here. Ooh, majority. We're going to need to know what that word means. Do I have any volunteers to help me? So what we're asked to do here is fill in the missing pieces of the table. And there's not just one right answer. And if you guys want proof of that, I can show you the answer key where like they would check your test with it, because this was a question from the test. John, you want to help me with one piece? Don't like give it all away.
Well, this is, I don't know if this is completely true, but 23 for the total of everyone, of every like single.
Yeah, and that they filled in for us actually.
No, for the males and females.
Yeah, you're right. It's filled in for us. It is right here. Yeah, so this box got filled in, but you're right that these numbers should add up to 23. So these two numbers in the total parts of male and female, these will add up to 23, and then we know something else about these two numbers of total boys versus girls. What's the next thing they tell us about boys versus girls? There are more males than females. There are more boys than girls. So my number of boys should be higher than my number of girls. What numbers could I use for boys and girls where boys will be higher? Lucas? Yeah, 10 is a really nice number. So I'm just going to make this 13 males and 10 females, because they tell us there are more males than females. Does that make sense? We could have used 12 and 11. We could have used 14 and 9, 15 and 8. Like, we've got different options. This just is nice in my brain, because I get to use 10. Anybody else to volunteer for the next piece we can fill in based off that information? We used this piece, right? We just used what was in blue. What's the next piece of info tell us? Read this if you haven't. Sorry, Antonella, was that a hand? So the next thing we specifically look at is on a school sports team. Right, so they're telling us to look at on a school sports team, and what do they tell us about the males versus females on the school sports team? Aiden? Yeah, fewer males than females. Guys, this means less boys. So we need to pick numbers here that this number for males is smaller than this number for females. Okay, so... Ooh, now wait a minute. Before I do that, that third piece of information might come into play also. The majority of females are not on a school sports team. Not on a school sport. What does majority mean? Yeah, more than half is really what majority means. So if we said there are 10 girls and I need to put the majority not on a sports team, what's the majority of 10? At least 6. You can do 6 or 7 or 8, but like 6 is probably a really good option. Because then how many would I put over here? 4. But wait, if I go back and look at fewer males than females are on a school sports team, what does that mean my number of boys on the school sports team could be? 3 or 2 or 1. Or 0. I mean, I guess we could, like, we don't know, it could be 0, but I think 3 is a good option there. Any questions up to this point? We're just taking the pieces of information and plug it. It's like a puzzle, guys. This is really like one of those just logic puzzles. So then what number am I missing here? 10, because it needs to add across to make the 13. So this would have to be 10. How do I get these numbers at the bottom? I add. Right? I find the total, so I'm going to total this up to be 7, total this up to be 16. And guys, I know some of you are real stressed out about the test. I'm just trying to prove a point, but I'm getting lost in the answer key. So in the key, exactly what we just ended up doing, I didn't guide us there on purpose. I hadn't even looked at this page yet.
But then there are other responses that also work if you put in some different numbers from the get-go. Yeah, so just based off what we fill in our table, then part B and part C, like there's not one right answer. So I want you guys to like step back from the ledge of concern. There's like, it's okay, this test, you'll be fine. So now we can answer part B, now that we filled in part A. So what's the probability that a female chosen at random is on a school sports team? Well, how many females do we have? We got to look at our female column. Yeah, on a team, 4 out of 10. So because they tell us we're choosing a female, we are for sure going to choose a female. Then they say plays on the team. So that would be 4 out of 10. What is the probability that a student, any student, male or female, chosen at random from Wilson's class, is then a male who does not play? Well, how many males do we have that do not play? 10 out of how many total students in Wilson's class? 23. There we go. We just had to go piece by piece with the information, fill in our table, and then we can go double check, is this true? More males than females. Yes, we made it happen. Is this true? Fewer males than females on a school sports team. Yes, we made that true. Majority of females in Wilson's class do not play sports. 4 versus 6. The 6 is the majority. We made that true. We check all of these boxes, even though there aren't actually boxes. Questions? I think y'all just got sad because I took my posters down. That's what it is. You're all just depressed today now. I know, right? Go ahead and look at this car trip question on your own. I think I'm going to reboot my software because it's lagging really hard. So I'm going to see if I can fix this. And there are pages of correct answers for that last problem. All right, so this one has a trapdoor where we might accidentally set the variables up backwards. So let's just start, first things first, of doing the math, and then we'll look at what equation to build, right? Because it asks us to create an equation. If I use 2 gallons of gas and get to drive 64 miles, what else could I say? Like, obviously there's some more data points on the table. Well, how do we normally talk about a car's efficiency? Miles per how many gallons? 1. How could I figure out the miles per 1 gallon? Guys, use a proportion. Set up 64 miles over 2 gallons. Well, how do I go from 2 gallons to 1 gallon? Divide by 2. What's 64 divided by 2? 32. Guys, and here's the trick. Not really trick, I need to get that word out of my vocabulary. The miles is the bigger number, right? 32 is definitely bigger than 1. So since the miles is the bigger number, it makes sense for us here to say the miles will be 32 times however many gallons of gas we burn. If I talk about the gas I need to use, and guys, you don't need to write both of these down, but I'm going to show it to you for the other example. the gas I need is 1/32 of the miles I would like to travel. Because going this way, it's 1/32, right? We're like dividing by 30. That seems complicated to me. That seems tough. I don't really like that. The amount of miles we need to, or the amount of miles we can drive, that equation makes more sense. But guys, either of these would get you your point, or 2 points, or whatever this question's worth. So, like, don't lock yourself into, I have to solve it a certain way. Think it through. Write it out with words if you want. We could say miles equals 32 times gallons, and check, is that true? Does the miles equal 32 times the gallons? Yes. This is true in the whole table. Questions? You are such an excitable group this morning. Try the next one on your own, because I bet, well, and how I split the sentence, I'll go ahead and highlight this. What's another word that we can use for mean? Average, right? So if you need to write a little reminder for yourself, mean, we do the average. How do we find that? Like, what math do we do?
Add them all up and divide them by the amount of
It is sum divided by quantity. Exactly what John said. I'm just going to abbreviate it. So we need to first sum these numbers. How do we sum them? Add them up. So go ahead and add up these numbers first. Guys, I would group them and make your life easier. I've got a 10 right here. And I've got a 10 right here. So now I'm at 20, 30. Did you get 40? Because I need you to double check my math. I might not be right. 10, 20, 10, 20, 30, 35, 38, 40. I think it's 40. How many people had he surveyed? Like, how many data points were there? 10. So we're doing 40 divided by 10. What's that get us? So the average, not kids, right, but people in your family. How many people in here have 4 people in your family? It's like mom, dad, brother, sister, or like you and a sibling. We have 5 in mine. Yeah, so like some families have more. But from this data, the average that people have is 4 people in their family. All right, in the next one, there really sort of is a trick, but I would like you to draw a circle. Does not have to be perfect. I don't think I have anything to draw a perfect circle with. Circumference is the distance around. Radius is the distance from the middle out, right? And diameter is our distance across the middle. My memory trick, that this really is kind of like a trick, is crust. Anyone eat a pie on Sunday with Easter dinner? Crust is pie dough. Crust is made of pie dough. But what this is actually telling us to do is to find the circumference, do pi times diameter. Pi times diameter. So we talked about this before spring break. That's why it may not have totally sat in your head. If you didn't do these joke worksheets that I haven't really collected, but if you haven't done these practices, you probably want to go ahead and try it and do some practice with that. So before we can use this. We need to figure out what the diameter is. Well, if the radius is 20, how do we find the diameter? Yeah, double it. So if the radius is 20, we can go ahead and write down, well, that means the diameter is 40. What do we use for pi? 3.14 times 40. What do they tell us to round to? Nearest tenth, so that we don't have a fight about pi. And that, if I just use 3.14, actually comes out to the 10th. 125.6. Now this kind of bothers me a little bit. The test will probably have your labels already in it. Drives me crazy because we spend all year trying to get you guys to put labels on your numbers. And when you go to take the test and type in the answer that you got, the label will probably be beside the box already. But if it wasn't, what label would this get? Centimeters. This next one, we're probably going to need some graph paper. And by probably, I mean 100%. Write that on your paper. Like, copy what they gave us. Oh, absolutely. So I am copying exactly what the problem gave me so that I can then do my work on this paper. If my pencil would work. When we have a number right up against parentheses, or really right up against anything, what is it telling us to do? Multiply. Now I guess we should have asked ourselves first, can we do the parentheses? Can we do what is inside? Can I do 2x minus 1? No, we cannot take 1 away from 2x because we don't know what x is. So since I can't take 1 away from 2x, I just move on to the multiplication step. Guys, this is critical. Draw your arrows so you don't forget part of the multiplication. I'm going to write out the whole thing. So this becomes 4 times 2x, and then 4 times -1. We'll do the other part in a moment. We'll come over here and do that in a moment. What is 4 times 2x? 8x. 4 times a -1? -4. So I could either write 8x minus 4, or I could say plus -4, if I want to actually write it like a negative. So we could either write 8x minus 4, or 8x plus -4. Any questions on that part of the problem? Because then the next part has some fractions. What is 3 times a half will be the first thing we have to figure out. What's half of 3? Well, we could either say 3 halves. Or what's another way we can say 3 halves? 1.5, right? 1 and a half. But guys, be careful. The temptation now is to forget the other multiplication. What's the other multiplication? 3 times 5, which is positive still, right? So I can put a plus between here. And since my 1.5x was positive, I can put a plus between here. Anything that's positive, I can put pluses between. Like here, doesn't matter. Because that's just grouping the -4. So thank you for pointing that out, but that is grouping the -4. We don't even have to have those parentheses. They're just nice. Well, we're not done. Because now, can I combine like terms? Yes. What is 8x going to be able to combine with? The 1.5x, and what are we going to get? 9.5x. What can the negative 4 combine with? 15. If you have $15 and take away 4, yeah, you still have positive $11. Now we're done, and now we don't have parentheses, right? It says do not use parentheses. Questions? All right, we all good? Check out the next one on your own for a second. I'm thinking this one would probably let you use a calculator. The way that I have been trying to brainwash you this whole year to solve any problem involving two different labels is to set up a proportion. So let's set up a proportion. It doesn't matter what you put on top or bottom, but I'm going to put feet on top just because it was the first number I wrote down. So we set up what we got told is equal. 3/4 of an inch is a foot. A foot is 3/4 of an inch. Where would I put my 7 1/2? Wherever you put inches. So yes, if you're doing it the same way as me on bottom, but it goes with your inches. So 7 1/2. And guys, we could do decimal. Especially if you're going to use a calculator. Writing in decimals might be easier for you to use a calculator. What's 3/4 as a decimal? 0.75. Because guys, think of money, right? Quarters. Think of money. 75 cents. So this is really 0.75 if we want to write in decimal. Ooh. Well, now those numbers look like they get along kind of nicely. Can anyone spot what I'm talking about here? Vincent? Yeah, to go from 0.75 to 7.5, we moved the decimal. That meant it multiplied by 10 or 100 or something like that. And again, if you don't know what to multiply by, divide it backwards, and we get 10 that way. So my numerator, what's going to happen to the numerator of 1 foot? Times 10 also. And this is going to be a large table. That would be a 10-foot long table. Good for gaming. I was just about to ask you as a favor, but it's all. What are you doing in language arts today? Yeah, I probably can't steal any of that time. Read the next problem on your own. You guys are smart. I bet you can figure this out on your own. Guys, I know that these past couple days have been sort of boring. I promise tomorrow, and don't be mad at me, we have math class, but we're not doing math. I'm going to either show you guys YouTube stuff or a couple people have sent me things this year. Might be a little long to show you guys, but I've got a documentary that I normally show. that talks a little bit about like math and nature and things like that. Like, so we have math class tomorrow. We don't have math on Thursday. Like, I didn't make the schedule, but you guys will come to my room after the test at some point tomorrow, and we'll just like watch TV. It'll be okay. Yes.
When we go to your room, can you have the meme I sent you up?
The what?
Meme.
The poem or what?
The meme I sent you.
I might have to look back in my email and double check, which a few people sent me things over spring break and stuff. Because the poem that you sent me was just mean.
It was a wonderful poem. Except that the thing showed up at the bottom, and I didn't want it to.
Well, no, I had to scroll to get to it, and that's what got me. Then I was like, ah! Vincent rickrolled me using a poem.
Oh, Benson.
All right, so Jamie goes to the grocery store to buy chicken and frozen green beans, but she only wants a bag of frozen green beans. So, guys, even though they don't give us a number, that kind of gives us a number. How many is a bag? 1. But we don't know how much chicken. So, the grocery store sells chicken for $4 a pound. And the frozen green beans, no one likes green beans anyways. No, I'm joking. I actually really like green beans. With some salt and pepper on there. Green beans cost $2 because, no one likes them. I'm joking. I don't like lima beans. Those are gross. So, this, and guys, this is what the test would give you. They give you the inequality. They say, this inequality is set up to help Jamie figure out how much chicken they can buy. So if Jamie only has $22, can they spend, like, here, based off what they tell us, does Jamie want to spend all of their money? No, because it doesn't have the or equal. So even though we know we could spend all of our money, Jamie doesn't want to spend all of it. So how much do we spend for sure? What are we buying no matter what? The bag of green beans. So this plus 2, I might as well take that out of my money. How do I take that out of my money? I minus 2 on both sides. And sorry I didn't leave you very much space here. We can pop over here now and say 4x is less than 20 now. If we minus 2 from both sides, solving just like an equation. Solving like an equation. So then, this is for what x? How are these connected? Is it 4 plus x? It's times, so we want to divide, right? This is multiplication, so we want to divide. But then what do we get? X is... Not x is 5. X is less than 5. X is less than 5. So you could buy 1, or 2, or 3, or 4, or 4.5, or 4.8, or 4.9. She just can't buy 5. Doesn't want to spend all of her money. Now, on the test that you guys take, they might let us equal, right? If this has the or equal bar, if we have the or equal bar, then we could buy 5. Questions? Go ahead and read the next one on your own. Highlight what's important. I'll take volunteers if you want to tell me what you think really matters or how we solve this. Highlight what's important, please. And I'm starting to really like that noise of the highlighters dropping in and out of the cups as people are like switching colors. I went to get my hair cut last night and I got into an argument with somebody about when do you ever use geometry. I won that argument. We were sitting there talking, and they were like, "Oh, wait, you're a math teacher? Let me ask you, when do you ever actually use geometry?" And I was like, "Bro, I'm a woodworker. You just sit down for a minute." That doesn't really matter here because this isn't geometry. I just wanted to brag about arguing with a stranger about math. I don't even know what his name was. He was just getting his hair cut also. Anyone want to help me with what's important here? Lucas? Kylie? Both you?
He left $150 each day for 6 days.
So what are we going to do with these numbers?
We multiply them.
Yeah, if it's 150 every day for 6 days, we're going to do that 150 times 6 to see what Sam actually collected. And man, Sam's bringing it in. What's 150 times 6? 900 is what Sam brought in. Good work. What's the next important thing, Kylie? 35% of the money is
35% of the money is
used for food. So we want to specifically pay attention to that because then the problem asks us, yeah, if you haven't read that final sentence, the rest of the money will be used to buy cleaning supplies. They want to know how much will be used for cleaning supplies. There are multiple ways we could do this. We could figure out 35% of 900 and see what's left over. Or what percent do we have when we start? Aiden, you want to talk me through this? You gotta speak up, man. You're right, but speak up. I just heard what you said. We had 100%, and then they did what? They use 35% of it. So what we have left is 65%. Then, what do we do with that 65%? Yeah, we're going to divide it by 100 or just get it into decimal form. Some of us are really good at this now. You just bump that decimal over 2 places. Gotta have sound effects. That times what? The 900, the money he brought in. We're using 65% for cleaning supplies because you got to keep that pet shelter clean for them. And you would have a calculator for this, but, if you didn't have a calculator for this, what is our nice little trick, thanks to Vincent and many of you, that we haven't used in a few weeks probably? What percent is nice to get to? 10%. If 900 is 100%, what is 10% here? 90! So guys, we could use the 10% rule and say 10% is $90. Go from there. I can multiply that by 6 and then do another half of it. But guys, you would probably have a calculator for a problem like this. They would probably let you use a calculator. But just in case, always remember the 10% rule, because then I can find 5%. How can I find 5% if I know what 10% is? Cut it in half, right? Divide by 2. That'd be $45. So we could get there a few different ways. But our final answer here, 9 times 6 is 540 plus 585. Somebody please double check that. Guys, I'm not any better at math than you are. Honestly, a lot of you are better than I was at your age. I just practiced. The more you practice anything, you start to make it look easier. It's not. I still got to think, right? I still got to slow myself down. But like I'm telling all of you, you're better. You're probably smarter than I am. So I became a teacher, right? I get to do the same thing every year. No one ever really pushes me to learn anything new. Just different students that I get to interact with. But guys, you're all really good at math. Just remember the stuff we've done this year. Let's flip to the back. We probably got time for... Oh, wait. Is that it? We finished! We finished! All right. Here is the deal. I will, if anyone wants to talk about anything specific tomorrow. Hey, hold up. Give me like 10 seconds. So that means like stop talking for 10 seconds, please. I know stuff's on the floor. It's okay. Tomorrow, if you want me to go over anything, I'm happy to do so. But I know you don't want to necessarily be the kid who like stops us from watching YouTube or whatever. Guys, we'll do that. We'll hang out for probably the last month of school and it'll be low stress. We'll do Desmo stuff. If you have things you want me to talk about, email me or come see me today and I can make a plan for tomorrow to review anything else you want to talk about.
What do we do with this?
Hang on to it. It's yours. Merry Christmas. Happy spring break. Although we're back now. All right, have a wonderful day, guys.